Welcome to Statistics Lesson 3, Trimmed Mean. So, in this entire statistics unit, what we are trying to do is put together some tools that tell us things about data. Specifically, most of the time we're talking about trying to find average or trying to find normal in a set of data. So we said that the mean is generally what we've done before in order to figure out average. Okay, we've often used those words interchangeably. But sometimes mean is actually not the best way of figuring out typical or average in a set of data. That happens when there are outliers. Okay, an outlier is a piece of data that doesn't really fit with the general group that you're working with. So let's say in your class, most of you have marks in the 60s and 70s in essential math, and there's one person who has 99% in essential math. That person who has 99% would be called an outlier because they don't fit with the main general group. Okay? And so taking them into account in the class average might not make a lot of sense because they are not typical compared to everybody else in the group. Okay, and so we have a tool called trimmed mean that we can use to kind of make the group a little bit more typical. So getting rid of an outlier is called trimming your data, and we're going to look at what that looks like in the example below. So we have a table here that contains a bunch of movies that came out in 2017. So they're all in order. You can see that Beauty and the Beast is the top one over here, $471 million. We're not going to worry too much about all of these digits over here. We're going to work in millions of dollars, and that's going to make this a little bit quicker and clearer. So Beauty and the Beast topped the box office at $471 million. Now we're talking about the live action version. I think that's what it's called, not the original animated version. This is an actual list. Then we had Logan, which is an X-Men movie, coming in at $223.5 million. Then Lego Batman, all the way down to 50 Shades Darker did the worst at $114 million. Okay, now if we look at this list, it becomes evident pretty quickly that Beauty and the Beast is just way out of everyone else's league. Right, the next one on the list is Logan, and it's less than half of what Beauty and the Beast made. So Beauty and the Beast is what we would call an outlier on this list because it's so much different than the main cluster. Okay, 50 Shades Darker might also be called an outlier, but it's not nearly as different as Beauty and the Beast is. So you could make an argument either way. But sometimes it's useful to figure out what's an outlier by putting them in order on a number line like this. So here we've got a number line. We're going to start it at 0, millions of dollars. This is all millions of dollars. This would be 50 millions of dollars. This one's 100. And I figured out what fits in here beforehand. So that's where these numbers came from. 400. 500. So on my number line, I needed all of my movies to fit there, right? So if I had a movie that grossed 600,000, this number line wouldn't quite work out properly because it maxes out at 500,000. But all of our movies fit underneath here. So 470,000. So this is 450 right over here. 475 would be right in the middle, and so 471 is about the middle, something like that. That one would be Beauty and the Beast. Not going to write the whole thing. But Beauty is right over there. Then Logan is about 225 million. So that's around here because this is 250. And here's 225. That one would be Logan. I'm not going to label what all of the movies are. I'm just going to put the rest of them on the list. Okay, so we've got Lego Batman at 175, which is somewhere around here. And then Get Out at 170, which is around here. And 165. And 164. And 137 is around here somewhere. and 137. Another one is right over there. And then 114 is more like over here somewhere. Okay, so this is our main cluster over here. Now, you could make all sorts of arguments about which values are outliers, which ones are in the main cluster, because really maybe you would say that this is the main cluster right over here, but 50 Shades is pretty close to the main cluster, so you might also include it. Logan is not nearly as far away as Beauty and the Beast, so it might be part of the main cluster as well. But there's some flexibility there. So we can see on this list that Beauty and the Beast, right over here, is obviously an outlier. It's just way different than everything else. The lowest one over here, 50 Shades, darker, is that a sequel? I don't know. That one, it's not really an outlier, but for the purpose of this, we're going to call it one. When you trim your data, you can't just take off one value. You have to take off an equal number from the top and bottom. Otherwise, you're making an unbalanced data set. So you've got to, if you're going to chuck Beauty and the Beast out, you've got to chuck 50 Shades out. So that keeps your balance on the top and bottom of your data. So we can see the top outlier that we're going to consider, and we can see the lowest outlier, and the range of the data is the difference between the lowest number and the highest number. So it's going to be a pretty huge range. Okay, so when we figure that out, we go 471 million, this is all millions, minus 114 million, and that gives us 357 million. So that's the difference between the highest and the lowest number. It's quite a big difference. That's a much bigger difference than what the numbers actually are in most of the cases. So let's figure out the mean here. When we figure out the mean, we just add up all the numbers and divide by the total number that there are. So there are 9 movies that we're considering over here, and we're going to add them all up and divide by 9. Now, I'm not going to take all of the numbers, the whole thing. I'm just going to take the millions that we're working with just to make it a little bit quicker and easier. So I'm going to write down that formula really quickly, and then we'll move on from there. So I put a ... in here because I just didn't want to write all of them down, but you get the idea. There's 9 movies added up there, and we're going to add them up, press equals, and then divide by 9. So when we press equals on the top, we get 1755. That's millions still, 1755 mil, divided by 9. So this is $1,755 million that these 9 movies took in. And when we divide it by 9, we get the average of all of them, which gives us 195 million. So if you're looking at 2017 and trying to figure out what does the average movie take in and how did your movie compare to the average, you get $195 million as the mean. But we talked about how Beauty and the Beast skews that average upward. Right, so this mean takes into account one very, very high grossing movie and then a whole bunch of kind of average ones. And so in order to get kind of a better picture, a more accurate picture of average or typical, we are going to trim our data. So what that means is we're going to take off the top outlier and the bottom outlier. Again, maybe the bottom number isn't really an outlier in this case, but you have to take off the same amount on the top and bottom. So when we do that, we're going to use the same mean formula. We're just not going to include the top movie or the bottom movie. So instead of starting at 471 million, we're going to start at 223 million. We start at Logan instead of Beauty and the Beast. And when we add all of those things up, it looks like this. Now notice that there's also no 114 on the list anymore, and I haven't divided by 9, because we're not taking 9 movies into account. We're taking 7 movies into account now. We chopped 2 of them off. And so when we do that calculation, we get 1170 for the top, and that's million. We have to divide that by 7 to get the average, or to get the mean. And from that we get $167 million. So our previous mean, not trimming the data, was $195 million. So that would be saying that the typical movie in 2017 took in $195 million. But when we take off that highest number, when we take off the highest outlier and the lowest movie, then we end up with a much lower average. So that's going to give us a better picture of what typical is for movies in 2017, because there was one that was just crazy. So how do they compare? So the mean, the regular untrimmed mean, is much higher than the trimmed mean. Trimmed mean is lower. By how much? By about $30 million. That's not nothing. Okay, and so trimming the mean is going to make a big difference to the mean if you have outliers in your data. Now let's talk very briefly about what effect does trimming have on the median and the mode. Because if you remember back to the first lesson, all 3 of those things are measures of central tendency. The search for typical, or the search for average. And so median would be another way of looking for what's a typical movie in this case. And mode is what's the most common number. So if we think about chopping off the top and bottom, what effect does that have on the median? It has an effect on the mean. What does it do to the median? Let me do a really quick example here. Let's just take these numbers, 0, 1, 8, 9, 9, 12, I don't know, 47. Okay, 1, 2, 3, 4, 5, 6, 7. 7 numbers. So when we find the median, we find the middle number. So if I have 7 numbers here, that means 3 on the bottom, 3 on the top. The middle one in between those is the median. Okay, so 9 is the median in this case. And if I chop off the top or the bottom number, and if I chop off the top number, then I'm left with 1, 2, 3, 4, 5, and it doesn't change the median, right? Because now 2 on the top, 2 on the bottom, that middle 9 is still the middle number. So trimming doesn't do anything to the median. Makes no difference. And most often, it's not going to do anything to the mode either. If we look at this list of numbers that I have used here, if we trim off the top and bottom, the mode is still 9, right? There's 1, 2, there's 2 9s and there's 1 of everything else. And so that means 9 here would be the mode. And if I chop off the 0 and the 47, it doesn't do anything to the fact that there are 2 9s. And so usually the mode will not change if you trim the data. So the only way that the mode would change is if your highest outlier or your lowest outlier is the most common number. And that doesn't happen very often because they're outliers. Okay, so trimming your data is going to make a difference for the mean. In cases where you have an outlier, it's going to kind of cluster your data a bit more to get a better idea of what typical is. So that's in the case where you have outliers, but it's not going to do anything to median or mode.